Hello everyone. So today, the day one of TCS NQT series by one of my famous YouTuber, and let's start solving this problem. So today we're going to solve first five problems in the series, like the number problems. So the first problem is climbing stairs. So you're climbing a staircase. It takes n steps to reach the top. Each time you can either climb one or two steps. In how many distinct ways can you climb on to the top? This is what my question. So I'm sorry, let me change my color of the pen. In how many distant ways can you climb to the top? Okay, let's see some sample test case. So if n is equal to 2, let's discuss, let's put a start case. So if n is equal to 2, I can either go from one step and another step. So the step number one plus one step, I can move forward, and either I can go for the directly to the second step. So two steps I can do. So totally, I'm going to take two ways to do this thing. Okay, fine. And if I'm going to have three steps, either I can go from one step to second step to third step. So I'm going to totally have one plus one, and either I can go from one step to second step, and one step I can directly go from one step, then I can directly go for the two steps value. Okay, I can either directly go for the two steps value, so I can pass it to one plus two steps, and I can directly go two steps behind, then I can go for the next third step, so two plus one. So totally then I'm gonna have three ways. Good. Okay. So I think you guys are able to understand, right? So how many distinct ways it is needed to climb to the top of your staircase? So they have given only two sample test case. Let's discuss one more sample test case. Like I'm gonna take n is equal to 4. So I'm gonna have a staircase. So this staircase is gonna be 1, 2, 3, and 4. So let me number it 1, 2, 3, and 4. Now I have these possible ways. So I can go for 1 plus 2 plus 3 plus 4, that possible way. And I can either, so the question given over here is I can either climb one or two steps ahead. So either I should take one step at a time or two step at a time. So I can go from 1, 2, then 3 and 4. This combination is also possible, and I can go for 1, 2, then 3, then 4. It is possible. Then I can go for 1, then 2, then 3 and 4 is also possible. Is there any other things possible over here? So I have climbed 1, 2, 3, 4. Two steps ahead and two steps ahead. First two steps ahead, there is one more possibility too. I can go one step behind, then two and three combined, and four. So totally, I have way number one, way number two, way number three, way number four, and way number five. So totally, I have five different ways. Yes. So this is what the problem is all about, guys. Either you can go with one step at a time or two step at a time, and you are supposed to reach to the top of the staircase. So you are supposed to find how many different distinct ways you are supposed to do it. I think so it's very simple. Okay, let's see what is gonna be our approach. So let me provide you an overview about the approach, then let me go to the code and let's start solving the code. What I'm gonna do, let's very important thing. Now I do know when my n is equal to 1 and n is equal to 2. Okay, now I can think that, okay, if n is equal to 1 or n is equal to 2, if n is equal to 1, I'm going to have only one case. So my total number of ways is going to be equal to 1. So here the answer is going to be equal to 1. Yes, I'm good. Okay. If n is equal to 2, let's check for this case. If n is equal to 2, I'm going to have 1 and 2. Either I can go from 1 plus 2 or 1, 2 directly. So there are two distinct ways. So I'm going to have the answer is equal to 2. If n is equal to 3, I'm gonna have my answer is gonna be same 3. I think so, right? So if I have staircase 3, 1, 2, 3, either I can go 1 plus 2 plus 3, 1, 2, 3, 1 plus 2, 3, 1, 2 plus 3. So I'm gonna have other three distinct ways. Answer is equal to 3. But When it comes to 4, the problem changes where the combinations are going to be different. Okay, let's test. Okay, now I got an idea. The idea is all about, now I do have some base condition over here. The base condition is if n is equal to 1 or n is equal to 2 or n is equal to 3. If any of the three other cases passes over here, I can able to say that the answer is going to be the same n value. But n is equal to 4, the answer changes. Okay, let's talk about how we are going to solve for n is equal to 4. Okay, what we can do, where if we find, like, if we want to store anything inside an array. Okay, yes, I got an idea. The idea is all about very simple, guys. Okay, let's see about it. I'm gonna have an array of containing 4 different elements, if the based on the size of n, and I'm going to store the first index as well as the second index with the value of 1 and 2. Let's store the value of 1 and let's store the value of 2. Now I'm going to make sure that I've filled the index number 0 and index number 1. Now I'm supposed to traverse from the second index to the nth index. What I'm going to do something bad. My ARR of 2 is equal to ARR of 0 plus ARR of 1. That means, major case, this ARR of I is equal to ARR of I minus 1 plus ARR of I minus 2. What I'm going to do something, but I'm going to add these two things. I'm going to store inside this, and it comes over here. I'm going to add these two things. I'm going to store inside, but I'm going to get the value at my index number last, so which is n is equal to. So when I'm going to return my ARR of n minus 1, then I can able to see my answer is going to be equal to 5. Okay, so what is the concept behind it? The concept behind it is very simple, guys. So the major thing is the arrays are filled with the number of position values. Okay, this is going to be step number 1, this is going to be step number 2, this is going to be step number 3. So even though we do have a base case called when n is equal to 3, we do have, when n is equal to 3, we're going to have written n as an answer. But we can solve this through the loop method too, so we can able to find the value as 3. So the major thing is all about, we are storing, I can able to get to a point over here. Yes, so what is the point is, the thing what we are doing here is we are storing the other number values. That means other distant ways, storing the distant ways. I'm sorry, guys. Okay, I'm storing the distant ways. I'm storing the distant ways in an array, so that I minus 1, then I minus 2 for I is going to be added to get the next distant way. So this is going to be the major concept, guys. Okay, so this is going to be the major concept. So let's start doing the problem. So it might be very simple, very simplest problem like what we have seen so far. So it's very easiest one. Let's get to our VS Code. Uh, okay, let's go for the climbing stairs. Okay, what I'm gonna do, let's give a new instance. So what I'm gonna do is, let's start. I'm gonna create a function and called as climbing stairs. Climbing stairs. I'm gonna pass n as my answer. That means my number of stairs which is there, and we do have a base condition. If my n is equal to 1 or n is equal to 2 or n is equal to 3, then I'm gonna return n as my answer. Okay, so even though you don't want to check for this thing, I want you to mention over here, you don't want to check for this thing. Okay, you don't want to check for n is equal to 3. But because the thing over here is, if rather than putting the base condition over in the first if condition, you can also use the array concept what I've just told you. Then you can start, you can get the answer for n is equal to 3 for answer 2. Okay, let's write the else case. First of all, let me create an array called as answer. In terms of Python, it's going to be list. let me append the first thing. So answer dot append of 1 as my first thing. Yes, it's supposed to. And answer dot append of 2 is going to be the next thing. Answer dot 2 append of 2 is going to be the next thing. So now I'm going to run the loop. So let's have for I in range of 2 to n. So after having for I in range of 2 to n, why? Because I've stored the index with 0 and 1. Let's append the next thing. It's very simple. Answer dot append of answer dot I minus 1 plus answer of I plus I minus 2. Okay, done. And then let what can I say? Let return the answer of n minus 1. Okay, fine. We are done with the case. We are done with the problem. Okay, let's have n is equal to 4, or let's directly print it. So climbing stairs, print climbing stairs of 4. Let's check the output. Yeah, we got 5 as an answer. Okay, let's see how it is being done in lead code. Okay, I've given you the same concept. Let's submit it. Yes. Okay, so we got our good, correct, approximate. So let's see for the time complexity. Guys, I wanted to mention over here that whenever you solve a particular problem, right, solve any problem, please try to note down the time complexity as well as the space complexity what you have. Okay, note down your time complexity and space complexity what you have. That might help you a lot while you are explaining your program to your recruiter. Okay, what gonna be the time complexity? Let me dump over this. Okay, what's gonna be the time complexity? As I said, so we said that I'm gonna have an answer array. So I'm gonna have, so this is gonna be a size of n. So the time complexity here, it is for this problem, the time complexity is gonna be big of n. Why? Because I'm gonna run the loop from 2 to n. Even though I'm running the loop from 2 to n, it covers n different time space units. So the time complexity is big O of n, and the space complexity is also big O of n. Why? Because I'm using an extra loop to store the frequencies, like extra loop to store the climbing stage value of other previous values. So it also takes big O of n, right? A prominent one. So I think so it is acceptable, right? Okay, let's get into the next problem of today's one. Yes, a very simple problem, right? Okay, program to check if a given year is a leap year or not. Okay, so I think so. This everyone knows, but I think so. You are supposed to know the exact condition of to check whether the given year is a leap year or not. Okay, okay. Let's talk about it. Let's have a year leap year is equal to minus one. So given year is year. Let me given. So this is gonna be my input, which is given. Okay, my conditions are as follows. Very important thing. My conditions are as follows. What are my conditions? The conditions are very simple, guys. Why? Because most of us, we know that we'll just check with one single condition and we'll move. That's not the case. We are supposed to check multiple conditions here. Once you have checked the multiple conditions, it's going to be very simple for you. Okay, let's check. So first of all, we know that the leap year should be divisible by 4. Yes, the leap year should be divisible by 4. First, we're gonna check if my year percentage 4 is equal to 0. You guys know that percentage symbol will find the remainder when it is divided by the number 4, which also states whether it is divisible by 4 or not. Now we guys know, now we know about it. The thing is, if the year is divisible by 4, yes, we can able to say it is an leap year, but we are supposed to know one edge case. If the year is divisible by 4, even though the year is divisible by 4, it should not be divisible by 100. It should not be a centurion. Let me give you a thing. If my year percentage 100 equal to 0. That means if year is a centurion year, let me provide you an overview here. If year is a centurion year, then the year is not a leap year. We can declare it, we can return over year itself. Year is not a leap year. LF, I'm gonna have another case. The case over here is, if my year is divisible by 100, we can able to say year is divisible by 100. Yes, my year is centurion. If though the year is centurion, it is divisible by 4, then the case is, if the year is divisible by 100 and year is divisible by 400, if this condition is being passed, okay, if this condition is being passed, then I can able to say my year is an leap year. Clear? So I'm gonna use an else if ladder, and it's very simple, guys. Why? Because leap year provide to check whether the given number is an odd number or even number or zero, positive or negative. To these kind of problems are very simple, but people won't recognize the optimal approach what we're gonna use, right? I can able to write this condition in one single line using ternary operator. Yes, I can able to write those things inside one ternary operator. I'll provide you the link below how to write the ternary operator. Okay. Or you can also write with this thing in one single line. One single line is also possible using logical operators. Okay. All these things possible. But what I'm trying to say is nothing. Please try to understand the overview. I'm gonna write an else if ladder. With the help of else if ladder, what you have understood, please make sure to write the next two things like using a ternary operator and single line. Okay. Okay. Let's solve the problem. So to check whether the given year is a leap year or not. Okay. To check the given year is a leap year or not. Okay. Let's write a function def check of year. Let me give an input as year. Okay. As I said, if my year is percentage 4 equal to 0. If my year is percentage 4 equal to 0, then my next case is nothing but, if my year percentage 100 is equal to 0, then if my year percentage 400 equal to 0, then I can able to say that print leap year. Yes, my year is a leap year. In this case, we can able to say if year percentage 400 not equal to 0, then we can able to say print not a leap year. Print not a leap year. And this else condition, that means if your year is not at all divisible by 100, then if year is divisible by 4, then we can able to say that the year is a leap year. Print leap year. Okay, guys, you may get to the condition, and I'm gonna close the last else. That is, if your year itself is not at all divisible by 4, then it is not at all a leap year. Okay, so print not a leap year. Okay, right? It's a very simple problem, guys. So I'm gonna give you some example. Let me have the year. Let me print the check of 2004. I get, it's a leap year where you can able to check it is a gonna get the value. Okay, so might give you, actually we are supposed to give, why? Because it's not going to return anything. So check of 2004 or 2006. 2006 is not a leap year. Yeah. So problem number 2 for day 1 is done. Okay, let's check for the problem number 3. So the time complexity is going to be big O of 1 and the space complexity is going to be big O of 1. You're not going to have anything extra. Okay, let's go for the next problem. Program to find whether the given number is even number, odd number, zero, positive or negative. These and all are base problems for each and every IT people, or not, I should not say it as an IT people, each and every engineering student should need to know, right? So we know that if a number, So we know that if a number, let's take a number to check whether the number is an odd number or even number. We know that if the number percentage 2 equal to 0, then it is a that's it, then it is an even number. Then if it is not divisible, then it is an odd number. Okay, giving you an overview, guys. That's it. Just brushing up your I should not say it brushing up your concepts, but I'm just awakening you about what and all you have learned while you're learning your programming. Okay, then if the number, so we can also see that if your number is equal to 0, then you can able to say your number is 0. If your number greater than 0, then it is your positive, and it want to check another condition. Why? Because if both the conditions fails, then else case is gonna be negative. Okay, so let me say the time complexity here itself. The time complexity is gonna be big O of 1, and the space complexity is also big O of 1. Why? Because I'm not gonna store anything else extra. Okay, okay, let's solve the problem. It's very simple. Let's check the number. F check number of n. I'm gonna provide each and everything what it is needed for it. So if n is equal to 0, I'm gonna print the value is 0. Lf n greater than 0, then I'm gonna print it as positive. And this else case is gonna be done print. I'm gonna have negative. One kind of process is done. If n percentage 2 equal to 0, then I'm gonna print even number, else I'm gonna print the odd number. So guys, these and all are very simple problems which is being asked in TCS. But the thing is, you are supposed to explain it clearly, or you are supposed to provide an insightful view overview. What and all things we have done in climbing stairs. Like you can also store the values, give the value for 3, that kind of like that. Okay, so print odd number. Okay, these are not very simple problems, guys. Okay, let's check the number. Let's check number of 10. It is both positive and even number. Yes, positive and even. Clear? Okay, problem number 3 of today, day 1 has been done. Okay, a kind of interesting problem. Print all the factors of the given number in sorted array. Okay, let me give you an insight about what are the factors of n in a sorted array. I'm gonna have a number as n of the given number. Let's have the given number n as 100. So what are the factors of 100? Factors of 100 are 1, 2. Whether 100 is divisible by 3? No. 4? Yes. 5? 6? I'm not sure. 6 is not there. 7, 8, 9, 10? No. The 10 is available. Then after 10, 15, 2s are 15, 3s are 45, 15, 4s are 60, 15, 5s are 75, 15, 6 are 90. No. So, and you have 20 and 40 and 50, then I think so comparatively then 100. Am I right? So I'm gonna have the series like factors. We are supposed to print all those factors in a sorted way. Okay, so the thing is you can able to find that I can able to run the loop to 1 to 100, but can able to see the time complexity is still big O of n. But if the n time complexity is big O of n, but my case is all about if an n is too large. If the n is too large, then we'll end up with another time complexity, or like time limit exceeded TLE cases will appear. So we are supposed to reduce the time complexity here. How we can do it? So I'm gonna make you another way, right? So first of all, the very important thing, I'm gonna run the loop. Wait, I'm gonna run the loop up to the square root of n. If 100, I'm gonna run only to 10. Why? Why? Because this is a case where I'm gonna find something else extra. Let me provide you an insight. For I in range of square root of n. If I'm gonna have like this, if I'm gonna run for I in range of square root of n, then I make sure that I'm gonna check. So why? Because only if it is divisible, then it is gonna be the factor. Am I right? If n percentage I equal to 0, then I is gonna be my thing. But this will run only from 1 to 10. Am I right? But remaining there is one more case like 20, like you also have 25, like you have 20, 25. So we also have 25 in the list, and 40, then we also have 50, then 100. So these are all the case, but how far we're going to print it? Let me give you an overview, right? Okay, now we have that value as 100. When the value of 100 is divided by 1, I'm going to get the quotient as 1 and the remainder as 0. Am I right? So it is divisible. When the 100 is divisible by 2, I'm gonna get the quotient as 50, and I'm gonna get my remainder as 0. When I can't able to divide by 3, I'm gonna divide by 4, I'm gonna get 425 some. So I'm gonna get the remainder as 0. When I divide by 5, then I'm gonna get 100, so which is 20. I'm gonna get the value as 0. Am I right? So 6 is not there, 7 is not there in the list, 8 is not there in this. And when I'm gonna divide by 10, I'm gonna get 10 tens are 100, which is equal to 0. So when I start pushing, like if I want to push answer dot append of I, then my answer will contain only these values. Am I right or wrong? My answer will contain only 1, 2, 4, 5, and 10. But unfortunately, we can't able to find the value called as star 20, 25, 50, and 100. Am I right or wrong? We can't able to find those values. Am I right? Yes. So we are supposed to put our case here. That's why I've divided here. Can you able to see when you divide, like when we found these numbers, when the 100, when the n is divided by these numbers, the quotient made the values over here. Am I right? I don't want to run the loop to till n. I don't want to run the loop till n. I'm sorry, it should be 1 times of 100. Okay, I can't able to write clearly over there. So the thing is, the quotient fills up the other numbers. So what we're gonna do is, it's we are gonna append I, as well as we are also gonna append the quotient of I, which makes a case in such a way that we can run our program only up to square root of n, not to n. So I've reduced the time complexity from big O of n to big O of square root of n, right? Okay, but I do want to make sure that I want to end up with some tail, right? I've made some want to be the like things. Okay, so first of all, what happens is nothing but I'll make sure that first of all my answer will look like this. So first of all, my answer will look like this. So first of all, I'll run the loop from 2 till 10. I'll run the loop from 1 till 10. So I'll add 1, and the quotient is going to be 100, 2, 50, 3 is not there, 4, 25, 5, then I'll add 20, and 10 and 10. Here the case appears. I can able to see that 10 has been appeared twice. Yes, so it should not be the case. So what happens is nothing but when I divide a number, when I divide the n with the number, I got a quotient. Am I right? I got a quotient. If both the quotient, okay, if both the quotient as well as the dividend, if both the quotient as well as the number what I'm going to with the divide is equal to each other, then I'm going to append only either of these two values, not the twice. This is going to be the edge case what I'm going to follow. Either I'm going to append the I, or I can able to append the answer dot append of n answer dot append of n divided by I. So I've explained you the algorithm as much as what I'm going to follow. Let's check the algorithm in our case. So find the factors. As I said, and made another value, like since math dot square root of n in Python is a floating value, I've typecasted it as integer and I made it to plus one. So it is a float value. It has been sealed over so it has been flowed over so that I make sure to add one to it end. And I check the same condition, guys. So if it is equal to 0, if both the quotient as well as your the value of I is equal are equal, then I make sure to append only the first only one value, or else I'm going to do the second value. Then finally I'm going to sort it. I'm going to return it. Yeah, let's check for 100. I have 1, 2, 4, 5, 10, 20, 25, 50, and 100 respectively. Clear? Okay, the final problem of day one is gonna be prime numbers. Yes. So prime numbers are very much simple, guys. Why? Because you all know about the concept behind what is prime numbers. Am I right? You all guys know about what is the concept behind prime numbers? Yes. The number which is divisible by one and it itself is gonna be called as prime number. But we can't able to go over there, then we have to supposed to know it. Okay, let's print all the prime numbers. Let's find all the prime numbers from 1 to 10. So according to our case, what are the prime numbers from 1 to 10? 2, yes, then 3, then 5, 7. Okay, these are the set of prime numbers. Am I right? 2, 3, 5, 7. So 1 is neither prime nor composite. 0 is neither prime, it will not come under the case. So that's going to be the edge case, right? So if my n is equal to 0 or n is equal to 1, then I'm going to return false. It's not going to be the prime number. Am I right? Okay, this is I found very much useful. Right, now let's go for the else case. Else case is nothing but though the number n is equal to 0 or n is equal to 1 is not going to be divided, not going to be make sure to get change anything costs. Why? Because one will be the number is can be divisible, it will be divisible by 1. Every number will be divisible by 1, so we are not supposed to check with 1. Okay, we are supposed to check with 2. So what I'm going to make sure that I'm going to start the value, the start the what can I say, I'm going to start the loop from 2. I'm sorry, I'm going to start the loop from 2 till n divided by 2. Why I make sure that? This is very important thing, guys. Some of them will run the loop till n. Don't do this thing. Loop loop till only n divided by 2. Why? Because after n divided by 2, none of the things is going to be the prime numbers. Okay, if I'm going to take 10 after 5, is there any other like, sorry guys, one sec. So make sure to have from n divided by one sec. It's not n divided by 2. It's another one. Okay. So from 2 to 2 to n divided by 2. Am I right? So why? Because we are going to check whether the given number is a prime number or not. Okay. We are supposed to check whether the given number is prime number or not. So this is going to be the case. Okay. So n divided by 2. Let's take. So let's take the given number is 10, where we have to check whether the given number is prime number or not. If we check only up to 5, 6, 7, 8, 9, we're not supposed to check. Okay, if the 5 is divisible, if the 10 is divisible by 5, then it is not a prime number. Okay, let's give you another example. 5. So 5 divided by 2, almost 2. Why? Because after 3 and 4 is not going to be much more divisible by much, will not divide the number 5. So in this case, I am making sure that I'm going to reduce the time complexity from n to n by 2. So I'm going to divide by n divided by 2. So yeah, now I'm gonna check if your n percentage I, this is gonna be I, is equal to 0, then we're gonna return false. Yes, gonna do it. Return false. Yes, yes. Okay. Else, if I'm gonna return false and this is gonna be done. Okay. Finally, if there's any other case is not done and false is not returned, I'm going to return true. Okay, can you able to understand the concept, guys? Okay, so the time complexity here, it is going to be big O of n divided by 2, or you can also say big O of n log n, where I reduce the time complexity from big O of n to big O of log n. Space complexity, not so much. I'm going to have big O of it. Big of one. Clear? Let's go for the problem solving. Okay, what's the problem? So I'm going to have the prime numbers. I've already solved it. N divided by 2. Why? Because I'm going to check plus 1. So I'm going to make sure. So I have the same code what I've written over there, I've written over here. Okay, let's check the first 20 the prime numbers within the range from within 20. Okay, 1 to 20. So we have 2, 3, 5, 7, 11, 13, 17, and 19 are your prime numbers. Okay. So why? Because this program is there to check whether the given number is a prime number or not. We have made it another loop to check whether this thing. It's a very simple concept. Okay, let's check for 10. So 2, 3, 5, and 7. Clear? Okay, so today we have done the first five problems of our TCS NQT SDE sheet. So thank you for listening. Please try to solve your problem in your series, and most of the problems are from Geek for Geeks and your lead code. Make sure to follow the lead code and try to evaluate all your test cases. So will help you a lot while you are solving the problem when you are writing the test on your own. So thank you for watching. So in the next video we'll start solving the day 2 as well as day 3, right? Thank you.